Oh, we are going to calculate the area under the curve. So on this figure, we have a curve which is a part of the circle. So something completing like this. And the square sector has the units 10 in the x direction and 10 units in the y direction. So the area of the square is 10 times 10, it is 100. And the area of circular region which is 1/4 of a circle. So area of the circular region is pi r square, which is again 100 and by 4. And if I get the ratio of the two, so the ratio by keeping the area of circular region above and the area of square below, it is going to be pi by 4. And since both these scales are linear, therefore the number of points falling in a region, they will correspond to their area. So let's only consider the integer points and see how good is this approximation. So I will generate the number of points. So I can generate these points. So it is 0.11, it is 0.12, sorry, 21. This is 3, 1, and this is 4, 1, and like that. And we can go up to the end point. So out of these 9 points, out of these 10 points, the 9 points fall inside the circular region and the 1 point goes off. So let's write a computer program. We can use the nested loops to do that. And we will calculate the ratio, and the ratio is going to be equal to pi by 4. So if I multiply the ratio with 4, so it will be an estimate of pi. So it is going to be an EPI. Estimate of pi is 4 times the ratio of the two areas, right? Okay, so let's program that one in Fortran. So since Fortran does not provide the visuals, therefore your logic should be very clear on a piece of paper. So I write the program. Okay. So program estimate of pi and program estimate of pi. So then the declaration stuff, implicit none. And let's save this one to our working directory, which is in the G77 folder, the bin directory. And Fortran freeform file. So estimate of pi dot for, and save that one. Okay. So these lines are correct. Okay. So I have integers. They must be declared with the keyword integer, even though I'm using it in the plural sense. So, and then real numbers are the count. So I count. I require the ratio. So I call it ratio. Then I require the area of square. So area, okay, area of square and area of quarter circle, right? So since the recording is going to keep my variable definitions, however, it is a practice to define AS for area of square, and likewise you have to define everything. Okay, so we would like to count the points. So I counts needs to be initialized at 0, right? Well, the number of points counts are going to be integers, I count, right? So integer. Okay. So now I write do I varies from 1 to 10, right? So 10 points are going to be generated in the x direction. Let's make it generalized and defined by n. N equals 10. Therefore, well, every variable should be defined. So there are some always some differences when you move from the concept or algorithm to the program. So n is equal to 10. So I can write now here n, and then I write do j for 1 to n. So I have to calculate the deciding criteria, whether it falls inside the circular region or outside. So we have to calculate the distance, right? So distance of point, it is equal to the square root of I square. So I write I square plus j square, right? And I have defined a variable dist. So therefore, I have to calculate distance, and it must be a real number because the sqrt is going to generate a real number, and it must have the arguments real. Therefore, I have to make this integer calculation shift it to real, so I can do such conversion with the float, right? So distance has been calculated. So I have to impose a condition. If the distance is less than or equal to 10, right? So then it means it is a point inside the circle. So I have to update the count. I count is equal to I count plus 1, and and if, right, nothing else is required, and do, and then and do. So okay, and after that I have to calculate the ratio. We found that our ratio is the ratio is equal to the I count. The ratio of the points is equal to I count divided by the total number of points. So I defined n equal to 10, but in 2 dimension, it comes out to be a pair of 10 cross 10 points. So there are going to be 100 points. So it should be n times n. So they are all integers. So I have to have one number converted to real numbers. So this is the ratio. So where we can compare the two things. So ratio is equal to pi by 4. So let's make it simple. If I multiply the ratio with 4, it is going to be something close to pi, right? So I calculate the estimate of pi, like I said, EPI. So it will be 4 times, it is going to be 4 times the ratio value, right? 4 times the ratio value will be the pi value, right? So let's print the results. So print the estimate of pi is equal to EPI, and the true value of pi, even though it is also the approximate, it turns out to be 4 times a tangent of 1, and that's it. So EPI has not been defined, therefore this is should be EPI. EPI is for estimate of pi from this calculation. Okay. So let's test our program. Okay. Okay. So we can see the whole program, right? Okay. So I have to run the program, and how to run it, I have to get to the directory. Oh, the directory is in scientific computing, and there is a G77 folder. Yes, there is the bin directory. So ESPI, estimate of pi.4, is program available over here, but I need to access that one from the system. So I write here CMD. So see this folder from the system interface. Okay. So I figured it out. The way to enlarge the view. Okay. So 24. Okay. So now I can compile with G77 espi.for minus O espi.exe. Let's look for the errors. Oh, there are no errors, right? So seems to be carefully programming. espi.exe. So let's see what we have been doing. We were calculating the area by calculating the ratios. So it means if this ratio is successful, it means the area can also be calculated. Okay. So let's see the output and look for the discrepancies. Okay. So the estimate of pi is 2.759999. So it is apart. It is away from the actual value, right? So what I can do, let me have 100 points in the x direction and 100 points in the y direction, right? So if I modify, then what will happen? The square dimension would exceed to 10 raised to the power 4, right? The Likewise, the area of the circular region will also exceed to pi by 4 times 10 raised to the power 4. However, the ratio would remain the same. So we need to make certain changes, right? So let's write it over here. The update, that let's consider n to be 100. So therefore, the points will become n square, and that would be 10 raised to the power 4 points. And also the area of the regions would also be multiplied. However, the ratio will remain conserved. So let's see what changes we need to incorporate in this program. So I'm going to change it to 100. So I varies from 1 to n, j varies from 1 to n. So distance. So this would become n square, right? So this would become 100, right? Now the radius of the circle inscribed in that square region would be 100, and counts would be generated, and float I count, that would remain same, n cross n, okay, 10 raised to the power 4. Okay. So counting the points on the grid, counting the points on the grid. So we have saved the program. We need to compile the updated program and then run it. And behold, the pi value is correct up to 1 decimal place, right? So I have increased the number of points. However, I have been using the integer set of points. So it means this problem can be simplified with the smaller region, right? I have enhanced the region. You can go to the smaller region and you can deal with the fractional part of the numbers, right? So generally people do to unity scale, and they count the number of points with their fractions, right? So fractional points from 0 to 1 and 0 to 1 with the steps of 0 0.1 or 0.01. So that's the strategy to improve those estimates. So let's stop at this point with this success of the concept demonstration and program demonstration, and enjoy it later on, because it contains the great things. But before that, let me show you what problem we have solved in this demonstration. So area of a circular region, if you write it, the problem area of a circular region, right? So area of a circular region is actually a double integral, right, on y and x, where y varies from 0 to the radius squared minus x squared, and then the x varies from 0 to the radius value. You can have that one, or you can have all that from 0 to r. Well, it's a custom to write the fixed values with the capital R, and then it is the r square minus x square root times dx. In this counting of points problem, actually you have solved a double integral, or to simplification, you have solved this type of integral with this simple analogy. Okay, so it's a great point to stop